Now you might recognise this graph. It's y equals 2 to the power x. Let's just check this. 2 to the power 1 is 2. 2 to the power 2, 2 squared, 2 times 2, that's 4. 2 cubed is 8. 2 to the power 4 is 16, and so on. 2 to the power 0 is 1. 2 to the power minus 1, let's just check this. That's 1 over 2, that's a half. Yes, that's right, that's a half. So this is the graph of y equals 2 to the power x. Now let's think of the equation 2 to the power x equals 10. This is the graph of y equals 2 to the power x. At what point does it equal 10? Well, it equals 2 there, it equals 4 at that point, it equals 8 at that point. So what value is it when x, what value of x makes 2 to the power x equal to 10? Well, one obvious way of doing this is to draw a line here, draw a line down, and we see that it's about 3.2, 3.3, something like that. Let's think about another equation, 3x equals 33. That means that x is multiplied by 3 to make 33. So x is 33, and then we do the inverse of multiplying. The inverse of multiplying by 3 is to divide by 3. So x equals 11. Let's go back to that other equation, which was 2 to the power x equals 10. So x equals, and then we need the inverse function of 2 to the power of. The inverse function of 2 to the power of is the logarithm to the base of. Two was our base, 2 to the power x is 10, so we need the logarithm to the base of 2 of 10. That's a bit of a long-winded way of saying it, so it's log to the base 2 of 10. Now on my calculator I've got a button, it's in the top right hand corner, it's got log, it's got a tiny little square, and it's got a bigger square, so that allows me to work this out directly. Log to the base 2 of 10 works out to be 3.32192809 or 3.32 to 3 significant figures. As a check, of course, I can do 2 to the power 3.32 and see that that equals 10. So here's another example. 5 to the power x equals 7, so x equals log to the base 5 of 7. Not log, log. And log to the base 5 of 7 works out to be 1.21 to 3 sig figs. Try to remember that the base of this expression here is 5. It's 5 to the power x, so the inverse function has log to the same base, 5, and then the other numbers swap over, because that's what the inverse does. It takes you back from the original number to the first number. So 5 to the power x, the base is 5, in log the base is 5, and then these swap over, the x and the 7 swap over. So if we take yet another example, 17 to the power 2x plus 1 equals 73. Then 2x plus 1 equals log to the base 17 of 73. Log to the base 17 of 73 works out to be 1.514. So therefore 2x plus 1 is 1.514343934. So to work out what x is, I take away 1 and divide by 2 to get 0.257 to 3 sig figs. Notice that I'm only rounding at the end.